Buckle up, folks. A massive earthquake hits, leveling cities and creating towering mountains out of skyscrapers. The chaos doesn't stop there. Imagine entire neighborhoods swallowed by a colossal glacier. But just when you think things can't get wilder, a comet bursts onto the scene, turning what's left into a fiery, ashy wasteland. Get ready for some mind-blowing facts. Our planet's got natural cycles of epic destruction that can take millions of years to play out. Talk about slow motion. If these doomsday events happen in sync, we're in big trouble. But here's the thing, one of Earth's most destructive forces is actually lying beneath our feet, waiting to strike. Meanwhile, let's travel back to the 16th century when Abraham Ortelius created the first ever world atlas. A game changer at the time. People back then thought the Earth was just thousands of years young and totally unchanging. Talk about a different perspective on our planet. Fast forward to Abraham Ortelius in the 16th century. He noticed something wild about his world atlas. The Americas looked like they'd been ripped away from Europe and Africa by earthquakes and floods. He thought of a massive biblical-style disaster, but nope, it was way more profound than that. It wasn't until over 3 centuries later when German geologist Alfred Wegener picked up on Ortelius' hunch and turned it into the continental drift theory. Basically, all landmasses were once stuck together as one supercontinent called Pangaea. As Earth rotated, it cracked apart, and these continents started drifting away from each other. And get this, according to Wegener, this massive movement was accompanied by catastrophic events that would have been a total nightmare for all life on our planet. Alfred Wegener's theory wasn't just about what happened in the past, he also predicted the future. He said our continents will eventually merge again into Pangaea Proxima, and get ready for this, Africa's west coast is going to smash right into America's east coast, wiping out cities like New York. Imagine Times Square being replaced with a mountain range as fierce as the Himalayas. Talk about a drastic transformation. Wegener even estimated that this mega crash could happen in just 2 million years. But hold up, geologists did some calculations and found that our continents are actually moving at an alarmingly fast pace of 2.5 meters per year. That's right, if we go by those numbers, the Statue of Liberty wouldn't stand a chance against the shifting continental plates. It would have toppled over just a century after its grand opening. The plot thickens. But don't worry, it turns out Wegener's prediction wasn't going to become a reality anytime soon. Thanks to satellite data, we now know that our continents are actually moving at a much slower pace of just 2.5 centimeters per year. That's 100 times slower than initially thought. This means the continents won't reunite into Pangaea Proxima for over 200 million years, not in 2 million like Wegener predicted. And when they do, it'll be part of an epic cycle that takes around 400 to 450 million years from start to finish. Talk about a geological timescale. But here's the coolest part. We now know this incredible process isn't driven by Earth's rotation as Wegener believed, but by the powerful convection currents of hot liquid magma deep within our planet. These natural forces are what push and pull the massive lithospheric plates in the Earth's crust, shaping our world in ways we're still discovering today. But here's the thing, scientists have discovered some mind-blowing clues suggesting our planet's supercontinent cycle might have been way faster in the past. We're talking 800 million to 1 billion years ago. That's an order of magnitude difference, and researchers are completely stumped about why or how this happened. Think about it, deep tectonic forces can cause volcanic eruptions that shake our planet. But events like Pompeii's destruction by Vesuvius just don't repeat themselves. They're one-off disasters. But when you look at geological history, some cities have been hit hard by powerful quakes, like what happened in San Francisco back in 1906. That devastating event almost wiped out the city and took up to 3,000 lives. Fast forward half a century, and another massive earthquake was brewing. But luckily for San Francisco, its epicenter was underwater, sparing the city from another catastrophe. This shows us that while some disasters might seem like one-time events, nature has an incredible capacity to surprise and reshape our world in ways we can only begin to understand. You know what they say, when it rains, it pours. In California's case, the San Andreas Fault is notorious for its short earthquake cycle. We're talking every 30 to 50 years. That's because the Pacific Plate keeps pushing against the North American one, building up massive pressure that needs to be released. Think of it like a giant cosmic game of catch-up Earth has to shake things out to keep the balance. And California's been on this cycle for centuries. The last big one hit in 2004, so buckle up. If history repeats itself, the next apocalyptic tremor could strike within the next 2 decades. But here's the thing. Faults all over the world have their own rhythms of seismic activity, yet we're still scratching our heads about what goes on beneath the surface. With so much mystery still surrounding Earth's interior, predicting strong quakes remains a huge challenge. And to make matters worse, sometimes earthquakes come out of nowhere. Defying any pattern or cycle we try to pin down. Here's a rewritten version of the script. Buckle up for some mind-blowing cosmic connections. Scientists are proposing that our star, the Sun, can actually charge Earth's mantle from the inside with its electromagnetic influence. Talk about a shockwave. When this energy is unleashed, it could trigger sudden and powerful earthquakes. But wait, there's more to our Sun's mystique. Did you know it has its own mysterious cycle of solar flares that still puzzle scientists? It all started in 1826 when German amateur astronomer Heinrich Schwab embarked on a fascinating quest. He was on the hunt for a hidden planet called Vulcan, believed to orbit between Mercury and the Sun. Schwab's mission: to catch a glimpse of this elusive celestial body as it slipped in front of the solar disk. Can you imagine the discovery if he had succeeded? Here's a rewritten version of the script. Let's dive deeper into Schwab's incredible quest to find the elusive planet Vulcan. For over 15 years, this determined German astronomer sketched sunspots almost daily. A meticulous approach that might seem old school now, but was crucial for his research. As it turned out, Schwab didn't discover Vulcan, but stumbled upon something much bigger, a pattern. He noticed that the number of sunspots tends to rise and fall in about a 10-year cycle. Little did he know, this groundbreaking discovery would send shockwaves through the astronomical community. Swiss astronomer Rudolf Wolf was particularly intrigued by Schwab's findings. Wolf took Schwab's observations and blew them up on a cosmic scale, gathering data for centuries and explaining the numbers. His conclusion: solar cycles actually last around 11 years, not 10. Here's a rewritten version of the script. Fast forward to September 1st, 1859, a day that would change everything. British astronomer Richard Carrington pointed his telescope at the Sun, but what he saw was unlike anything before. Huge, gigantic spots appeared, each one massive compared to our Earth. It was like gazing up at a celestial display of fiery eruptions. And then, it happened, these colossal sunspots unleashed an enormous blast of superhot plasma, similar to a cosmic volcanic eruption. Little did Carrington know, this spectacular event would trigger a chain reaction that would send shockwaves all the way down to Earth. Buckle up. If our planet were right next to the Sun during this colossal event, it would have been toast in an instant. But since we're safely at a distance, you might think we'd be okay. Think again. By evening of that same day, Earth felt the powerful impact of the Carrington event. The Northern Lights put on an epic light show, stretching from Canada all the way to the Gulf of Mexico. Meanwhile, telegraph operators, basically the internet pioneers of their time, got a nasty surprise when they tried to send news about it. They received electrifying shocks and even suffered burns. This intense solar storm pummeled our magnetic field so hard that it left a lasting mark in history under its infamous name. The Carrington event. This ain't over yet. Fast forward to 1921. A solar storm rocked our world by taking down phone lines around the globe. Then, in 1972, a geomagnetic storm lit up the seas off Vietnam's coast by detonating U.S. Navy mines. Just when you thought it was safe, another powerful strike hit in 1989, plunging Canada's province of Quebec into darkness. And if that wasn't enough, get this, in 2012, we got a second shot at reliving the Carrington event. But just as fate would have it, Earth narrowly escaped a devastating plasma ejection at the last second. It was a cosmic close call and a stark reminder of our planet's vulnerability to space weather. Buckle up, folks. If a massive solar storm comes knocking, our cities could be plunged into total darkness in an instant. With planes falling from the sky and all gadgets burning out, no more sharing creepy selfies on social media. We'd be thrown back to the 19th century overnight. The good news is it's not a question of if, but when. Scientists have cracked open the mystery of solar cycles, uncovering 11-year patterns, plus centuries-long rhythms of minimums and maximums. But here's the rub. They still can't pinpoint what drives these cosmic forces or where we stand on the solar apocalypse meter. It all comes down to the sun's secrets, from its internal workings to the unknown space forces that sway it. The truth, we're just scratching the surface of this astronomical enigma. Fast forward to 2019, we're now riding the waves of solar cycle number 25. So, when can we expect the next Carrington event? It could be as early as 2030, or maybe we'll have to hang tight until the 2060s. The wait is on. Here's a mind bender come what may. We're looking at this epic solar flare happening within the next 150 years. Now, you might think the sun's just here to scorch us, but hold up, it's also our cosmic dance partner, keeping Earth in orbit around it on. And let me tell you, it's no perfect circle, nor is our pace constant. But here's where it gets really cool. Our cosmic ballet with the sun isn't static. Every 100,000 years or so, Earth's orbit goes through this wild oscillation called eccentricity, stretching and shrinking in a crazy dance. Meanwhile, its axial tilt is doing its own thing, swinging back and forth over a 1,000-year cycle. And then there's precession, our axis tracing out a circle every 3,000 years. When these cycles all come together just so, guess what? We get an icy chill, and a teeny tiny amount of sunlight reaches Earth, setting the stage for an ice age to begin. Picture it, a gargantuan glacier creeping up the streets of Chicago or London, transforming these bustling cities into frozen wastelands. Millions would be left in the icy grip of death, and survivors would have to make a desperate dash south for warmth. This is what an ice apocalypse looks like when our sun's rays take a rare break from Earth, a phenomenon that unfolds every 1,000 years. Serbian genius Milankovitch cracked this cosmic code a century ago, earning the cycle his name. But here's the twist: geologists tell us these ice ages don't always stick to the script, sometimes dragging on for much longer than expected. But here's where things get really interesting. Milankovitch's cycle has an extended version running at 100,000 years, and scientists are stumped as to what causes this glitch. According to our current doomsday countdown, the next ice age was due in 10,000 years. However, thanks to humanity's massive carbon footprint over the past couple of centuries, it looks like we've just bought ourselves some extra time. Or have we? A more pressing threat might be lurking on the horizon, a nuclear winter triggered by our own making. And speaking of predictions coming true, I made one last year that seemed far-fetched back then. But now it's starting to unfold before our very eyes. But before I dive into that prediction, let's look at something even more mind-blowing. The fact that totally unexpected factors can crash into these cyclical patterns and set their own catastrophic clocks in motion. Life on our planet has hidden rhythms, making it super tough for us to unravel them. A fascinating example from history is when French naturalist Georges Cuvier stunned scientists in the late 1700s by claiming that elephant bones he'd discovered in Europe actually belonged to extinct mammoths. A revelation that sent shockwaves through the scientific community, because everyone thought that no species had ever gone poof on Earth, let alone new ones popping up. The real kicker is that Cuvier believed mammoths went extinct due to some massive, planet-rocking disaster, think superstorms, and huge floods smashing into Earth every few thousand years, wiping out life and then rebooting it. But the scientific crowd was having none of this. They called it catastrophism and totally roasted Cuvier. Even Charles Darwin, the future father of evolution, wasn't completely on board. He agreed that species did swap out, but thought it was all about gradual change through natural selection, not some big cosmic wipeout. Fast forward to now, Darwin's ideas really took off, and we discovered that most species only last anywhere from 5 to 10 million years before making way for the next big thing. So when mammoths first showed up around 5 million years ago, they quickly became the undisputed champions of the far north. They reproduced like crazy and ruled the roost as top dogs. But then, a major game changer hit. These massive creatures were challenged by a brand new predator in town, Neanderthals. However, it was only around 40,000 years ago that the real history makers arrived, dethroning both mammoths and Neanderthals to become the most successful species we know today. But here's what really went down. These clever Homo sapiens didn't just dominate their surroundings, they took it to the next level by knocking out Neanderthals first, and then finishing off mammoths about 5,000 years ago. Today, we know that our human ancestors have been around for an astonishing 2 million years. And with no major competition in sight, it's safe to say our species has at least half of Earth's history still ahead of us. We've managed to conquer nearly the entire planet and even wiped out most of the deadliest predators. From a purely evolutionary standpoint, Homo sapiens are well on their way to becoming an almost eternal species. But little did we know that one scientist's ideas would change everything. Fast forward to 2021, when a team of American scientists made a groundbreaking find that left everyone stunned. They published their discovery in the Geoscience Frontiers journal and revealed that Earth isn't as steady as we thought. It turns out our planet has a cycle of mass extinction events happening every 27.5 million years. That's right, Earth has a pulse, and with each beat, thousands of species vanish from its surface. But here's the kicker, these catastrophic events aren't just repeats, they're completely unique each time. And it seems like Cuvier was onto something when he talked about floods caused by ocean level changes being behind one of these extinction pulses. These cycles of extinction aren't just about flooding. Another beat sees glaciers roll in and snuff out life-loving species that thrive in heat. The thermophilic ones are the first to freeze out. And then there's the one that shatters the Earth with a supervolcano eruption, spewing devastating ash into our atmosphere. Mind-blowing fact, scientists believe it was just such an event around 70,000 years ago when the Toba supervolcano unleashed its fury and pushed humanity to the edge of extinction. It's estimated only about 3,000 ancestors survived that terrifying catastrophe. And here's the kicker, this wasn't even part of Earth's eerie, mysterious pulse cycle R. Just imagine how much more destructive those regular beats must be. But here's the silver lining. We've got about 20 million years before the next cycle hits. That's plenty of time to prepare and get our act together. But wait, if we don't crack the code on what's driving these pulses, all that prep work will be for nothing. Now, scientists are stumped trying to find a mechanism behind these disasters: floods, glaciation, earthquakes, the whole shebang. They've looked into continental drift, changes in Earth's orbit, and even the sun's unpredictable behavior, but so far, nada. It seems we might need to think bigger, like a global force that goes beyond all those factors. The question is, what could it be? Let's flip back to that infamous mass extinction chart and take a closer look at what sets one event apart from the rest: the asteroid impact that wiped out those iconic dinos. You've probably already guessed where I'm going with this. This massive space rock collision might just hold the key to understanding Earth's pulse beats. But here's the mind-blowing part. It seems to line up with one of our planet's pulse cycles. So, how can an asteroid impact possibly be connected to a natural cycle of disasters that supposedly comes from within? It doesn't make sense. Shouldn't our planet avoid self-destructing with asteroids? You might think that space disasters, like asteroid crashes, are random events that don't follow any pattern. And in a vast universe, it's hard not to believe that anything's possible. But here's where things get really wild. Researchers have been scratching their heads over an even bigger mystery for nearly half a century. It all started back in the late 70s when geologists Walter and Luis Alvarez stumbled upon the Chicxulub crater, created by a massive asteroid impact in Mexico's Gulf region. Since then, hundreds of scientists worldwide have joined forces to figure out when will Earth face another catastrophic asteroid assault. To crack this code, we need to uncover the timeline of all these killer crashes that have shaped our planet's history. Imagine trying to find clues about a massive event that happened just a few thousand years ago. It's like searching for a needle in a haystack. But instead of a needle, you're looking for signs of an apocalypse. Take the ancient city of Tal el-Hammam in Jordan, for instance, which mysteriously vanished around 1650 BCE. Over the years, archaeologists have proposed various theories, but it wasn't until recently that they uncovered some crucial evidence: melted stones, burnt belongings, and a thick layer of ash over 1.5 meters high. Now, since there aren't any volcanoes nearby to explain this destruction, scientists are left with a chilling conclusion. A small comet or asteroid must have struck the Earth. instantly incinerating everyone and everything in its path. But here's the twist: instead of hitting the ground, it seems this object exploded mid-air, unleashing unimaginable destruction from above. This ancient asteroid explosion above Tal el-Hammam eerily mirrors what happened in 2013 when the Chelyabinsk meteor lit up Russia's skies without causing any massive craters. Some even link this event to the biblical tale of Sodom and Gomorrah being consumed by fiery destruction, but from a scientific standpoint, it's crucial to separate fact from fiction. Now, you might think that a massive asteroid capable of wiping out humanity would definitely leave its mark, like a colossal crater, for instance. But here's the thing: our planet has natural processes like erosion and weathering which can skillfully cover up even the most dramatic impact signs over time. As a result, scientists have had to dig deep into history books to document only about a dozen major space disasters over the past 2 billion years. It doesn't seem like we're experiencing any sort of catastrophic cycle. So, based on their best calculations, astronomers say that a doomsday impact might hit us once every 4 or 40 million years. Talk about an unpredictable timeline. That's why predicting the next one is basically mission impossible. To mitigate this risk, NASA has been working tirelessly for 2 decades and pouring in massive resources to track down all potentially hazardous near-Earth asteroids. As of now, they've managed to locate more than 90% of these threatening objects lurking between our sun and the asteroid belt. And according to their findings, it's looking good. We're safe for at least a century, or even 1,000 years from any major space impact disasters. But here's the thing: all those asteroids NASA's been tracking are just a tiny fraction of the space threats waiting in the shadows. Let's talk about the Oort cloud, this enormous, 2-light-year-wide bubble hiding comets beyond our reach. Think of it as an almost invisible cosmic ocean teeming with potential space killers. Now, scientists have stumbled upon something mind-blowing: a mysterious cycle that seems to be sending these comets hurtling towards Earth at regular intervals. It's like the universe is holding its breath, waiting for the next big impact. Get ready for a jaw-dropping discovery. In August 2022, Aussie researchers at Curtin University teamed up with North American scientists and uncovered some seriously ancient secrets buried within their nation's tectonic plates. And here's the kicker: they found the same patterns on both sides of the globe. By analyzing crystalline deposits from around 3.5 billion years ago, they pieced together a catastrophic event that would change Earth's history forever. A colossal comet traveling at an insane speed of 60 to 70 kilometers per second Delas, that's 3 times faster than the asteroid that wiped out the dinosaurs, slammed into our planet, punching through the crust and sending shockwaves all the way down to the mantle, transforming the entire ocean-covered world into a lava-spewing, molten mess. Imagine a cosmic difference between a tiny crop duster and a massive jetliner. That's the scale we're talking about here. The mind-boggling speed of this ancient comet, reaching up to 70 kilometers per second, screams one thing: it didn't come from your run-of-the-mill inner solar system. Nope, this extraterrestrial visitor hailed from the vast Oort cloud, a distant, icy reservoir on our solar system's fringes. But wait, there's more. You'd think this was a one-time event, right? Wrong. Scientists dug deep into Earth's geological layers and found that similar global lava spewing catastrophes weren't isolated incidents. In fact, they happened about every 170 to 200 million years, with hardly any exceptions. The weird thing is, no such regular cosmic cycle exists in our solar system. It's like the Earth was hit by a massive cosmic bullet train, and we still don't know why or how. But hold on, because the cosmic context just got a whole lot bigger. You see, our solar system isn't standing still. It's hurtling through the Milky Way galaxy at an incredible 240 kilometers per second. That's like flying at supersonic speeds. And guess what? It takes us about 225 million years to complete one full rotation around the galaxy's central supermassive black hole, a massive cosmic heavyweight lurking some 20,000 light years away. Now, you might be thinking, wait, is this finally our answer? But don't get your hopes up just yet. It's not the exact cycle we're looking for, but it's definitely part of the bigger picture that might hold the key to understanding these mysterious cosmic collisions. But there's more to our galaxy than just a lone solar system zooming through space. It's a bustling, swirling cosmic metropolis with sweeping spiral arms packed with stars, gas, and dust clusters. These majestic arms take about 200 million years to complete one full rotation around the galaxy's center, creating zones of higher density where gravitational forces are at play. It's here that scientists believe our solar system could get caught up in an intergalactic game of cosmic billiards. When we enter these denser regions, external gravity starts to disrupt the Oort cloud, a far-off reservoir of comets. This gravitational tug-of-war can send those icy bodies hurtling towards Earth at incredible speeds, potentially causing massive collisions that could have shattered supercontinents and sped up our planet's cycles throughout history. These colossal cosmic collisions weren't just random events at all. They had a ripple effect that reshaped our planet. The massive impacts triggered by these cometary crashes could have plunged Earth into prolonged ice ages, or even wiped out entire species in an instant. But that's not all. Our sun's magnetic shield is also put to the test when we navigate through the galaxy's dense regions. As we pass through these cosmic traffic jams, the sun's magnetic field gets overloaded, and it starts firing off more frequent plasma bursts. And guess what? Aussie geologists believe we've been here before. They think our solar system last cruised through one of these galactic arms a whopping 66 million years ago, just when the dinosaurs were getting ready for their final curtain call. You'd think we've got plenty of time before our next cosmic collision, a comfy 130 million years to prepare for impact. But hold on to your seats, because this comet cycle isn't as predictable as you'd hope. There have been times when massive impacts happen despite the solar system being in a safe zone, far from these dense galactic regions. Now, check out these mind-blowing animations of our home galaxy, the Milky Way. But here's the thing, even with all these stunning visualizations, astronomers are still stumped about how many arms this spiral beauty has or exactly where they're located. Imagine this, over 90% of the Milky Way lies hidden beyond its radiant center, a vast, uncharted territory shrouded in mystery. And here's another twist. Those same gravitational forces that shape our galaxy can also create invisible clusters of dark matter, invisible to our telescopes. Now, picture this right now. Possibly hurtling towards us from the far reaches of the Oort cloud is a killer comet we're completely unaware of. If that's true, our best bet would be to mobilize every nuclear arsenal on Earth in an attempt to deflect it and break what could become Earth's most deadly cosmic curse. But here's the catch: our ability to dodge this cosmic catastrophe depends on our success in confronting another kind of destructive cycle, one driven by human nature and the world economy. Think back a year when I shared with you Austrian sociologist Arnaud Tosch's groundbreaking research from 2007. He mapped out every major conflict since the late 15th century, revealing a striking correlation between global economic trends, like the devastating Great Depression of the last century, and nations' propensity for war. It's as if countries have an internal clock that prompts them to engage in conflicts at regular intervals. What makes this even more concerning is Tosch's observation. After World War II, we entered a prolonged downward phase of this cycle, suggesting we're now due for another peak. The question is whether these ominous cycles are more than just theory. Just a couple months after I shared this idea in my video, Russia's invasion of Ukraine shook the world, leaving many wondering if it might be an opening act for something even more catastrophic, a third world war. While some believe in secret patterns driving human destruction, others remain